Welcome to this explainer video, where we'll be diving into the fascinating world of science and exploring Isaac Newton's groundbreaking discoveries. You'll learn about his laws of motion and the theory of universal gravitation in a simple and engaging way. Isaac Newton was a brilliant physicist and mathematician who lived in the 17th and 18th centuries. His ideas revolutionized the way we understand the natural world, and they continue to shape our lives today. So let's begin with his famous 3 laws of motion. Newton's first law, also known as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and direction, unless acted upon by an external force. Imagine you're riding a bike and you suddenly stop pedaling. You'll continue to coast forward, gradually slowing down due to friction and air resistance. The second law focuses on the relationship between force, mass, and acceleration. Simply put, it can be expressed as F equals ma, where F is the force applied to an object, m is the object's mass, and a is the acceleration the object experiences. This means that the greater the mass of an object, the more force is required to accelerate it. For example, consider pushing a heavy shopping cart. It takes more force to get it moving and accelerate it than it would for a lighter cart. Similarly, if you apply the same force to 2 objects with different masses, the lighter one will accelerate more quickly. Now let's move on to Newton's third law, which is often summarized as, for every action, there is an equal and opposite reaction. This means that forces always come in pairs, and when one object exerts a force on another, the second object exerts an equal and opposite force back on the first. Think about jumping off a diving board. As you push down on the board pushes back on you with an equal and opposite force, propelling you into the air. This concept applies to all interactions, whether it's a rocket launching into space or simply walking on the ground. Now that we've explored Newton's laws of motion, let's delve into his theory of universal gravitation. This revolutionary idea states that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. In simpler terms, gravity is the attractive force that exists between any 2 masses. The greater the mass of the objects and the closer they are to each other, the stronger the gravitational force between them. This concept is expressed in the formula F equals G asterisk m1 asterisk m2 slash r squared, where F is the gravitational force between 2 objects, G is the gravitational constant, m1 and m2 are the masses of the objects, and r is the distance between them. Because of this law, we can understand why the planets orbit around the sun, why the moon orbits around the Earth, and even why objects fall to the ground when we drop them. Gravity is the glue that holds our universe together, and it's all thanks to Newton's brilliant insights. It's important to note that Newton's theories have been expanded upon and refined over the years. Most notably, Albert Einstein's theory of general relativity has provided a more accurate description of gravity, especially in situations involving massive objects or extreme distances. We've made a video on the subject, so don't forget to watch it. However, Newton's laws of motion and universal gravitation still hold true in many everyday situations, and form the foundation of classical mechanics. These concepts are essential for understanding a wide range of phenomena, from the way objects move on Earth to the behavior of celestial bodies in the cosmos. In conclusion, Isaac Newton's laws of motion and theory of universal gravitation have had a profound impact on our understanding of the natural world. Through his discoveries, we've gained invaluable insights into the fundamental forces that govern the universe. So the next time you see an object in motion or think about the planets orbiting the sun, remember the incredible mind of Isaac Newton and his lasting contributions to the world of science.